guys, thanks for joining. I know it's kind of troubled times out there, but they will pass. And so I appreciate you getting on the call and learning about Intel technology. We have a big cycle coming up here. We have a lot of changes, competition's coming at us hard, and we're going to talk through all of that. If you have a question, unmute, ask a question. You guys can do it real time. You don't have to wait for, a break or to the end or anything like that. Feel free to ask questions. So with that said, let's get started.
So we're focusing on the spring. I'm saying spring / back to school timeframe because it's kind of munged together. There's going to be kind of rolling products coming out, like as an example, the Ice Lake Y product, the 10th gen Intel Core Y series is out, right? It's in production. There are some systems out there with that. As well as a new Gemini Lake, so Pentium and Celeron, the small core parts. Those two are in the market now. And the next thing you're going to see, starting next month, is going to be the 10th gen Comet Lake H, the mobile part down at the bottom there. And the Comet Lake S, the desktop family, will be more like a late spring type time frame. So we're going to cover all of those parts this cycle, and then I'll give you kind of some holiday tidbits as we go through this. So let's start by focusing on the desktop part, Comet Lake S. What's new about it? All right, so first off, we're doing a complete line update. So whether it's all-in-ones or towers or gaming systems, even all the way down to Celeron and Pentium, the entire family gets updated to Comet Lake S. And with Comet Lake S, what we've done for the core family, Core i3, 5, and 7, is we've enabled hyperthreading. So if you remember back in 8th gen, we had, as an example, 6 cores, 12 threads on the i7. Then we went to 9th gen, we went to 8 cores without hyperthreading. Right? Still better performance, but hey, you lost that feature, which is kind of a bummer. Well, now with Comet Lake S, we enable that back in there. So AMD kind of caught us for a brief period there where they enabled their multi-threading technology and we didn't have ours turned on. Well, that's all gone now. So we have multi-threading turned on, and we juiced up the performance. The frequency's up to 5.3 gigahertz now. So tremendous gains in megahertz over the competition and performance. We also introduced 2 new technologies called Intel Turbo Boost Max Technology 3 and Intel Thermal Velocity Boost Technology. Now, guys, I don't expect you, or for the most part, even want you talking about these things to customers, right? Because that means you're already way in the dirt. But it's good for you to know these things, because if you do come across it, at least you've heard of it and you understand what it is, because it is a pretty big deal, and I'll explain that on the next slide. Of course, and we do this just about every time, the new K SKUs of the family, we've enhanced the overclocking for both the core and the memory, as we do pretty much every time, making it easier to overclock, and that's a big strength for Intel in the gaming segment, is the overclockability as compared to our competition. And then also, we're integrating Wi-Fi 6, both in this product as well as Comet Lake H, so for the mobile gaming products. So our entire family now has integrated Wi-Fi 6. Wi-Fi 6 is for the modern home. We've talked about this before. You're pretty much nuts if you don't get Wi-Fi 6 moving forward. Devices, routers, all those type of things. Because it relieves congestion, it lowers latency, it supports more devices, all the devices that you have in the home work much better. And then also, of course, we always have this advantage with all of our products now, is support for the Intel Optane Memory H10 with solid state storage. So that's a differentiator for us on the higher performance system. I basically like to, kind of draw a line, at least on notebooks, $1,000 or more. You really want that performance SSD in there. And the H10's really the best solution out there for that kind of high performance type system. So let's take a look at those 2 new technologies.
Intel Turbo Boost Max Technology 3 is for both the i7 and the i9. And before, when you saw turbo frequency, it was for a single core, right? We would go through each one of the parts, every single processor, and identify the best core and use that for that single core turbo. Well, now with this new methodology, or Turbo Boost Max Technology 3, it rolls off your tongue, we identify the best two performing cores, and both of those get to run at turbo frequency, at that maximum turbo frequency. So it's nuanced. It's nothing you're going to see on a fact tag or anything. But now think about it. A lot of applications, if not most applications, can make use of two cores. And now you get that higher performance frequency for both of those cores. So dual threaded applications now can take advantage of that high frequency, whereas our old parts would have throttled down to a lower frequency, a lower boost frequency. Also, Intel Thermal Velocity Boost is really just for the Core i9 product lines. And what we've done is we've kind of stole that feature from the mobile gaming products, right? So in the mobile, we had this before, which is basically, hey, if you could keep your processor cool enough, which is easier to do in a desktop tower because you have, water cooling and everything else. If you could keep it cool enough, we'll get you all the way up to 5.3 gigahertz on the Core i9 family. So these are big numbers, and again, on top of that, you'll still be able to overclock if you're into that. Two big technologies that helped our performance in this transition. Let's talk a minute about Comet Lake H. So Comet Lake H is the new, I'll say, gaming standard, right? We have 9th gen today on shelf. 10th gen is going to hit. You'll start to see systems on shelf starting April 15th. So right at that tax day, or what used to be tax day, maybe not this year, tax day, you're going to see these new systems. And it's not just an Intel refresh, guys. So what I understand, though I'm not privy to any kind of NDA material from NVIDIA, rumor has it that they will also have new gaming graphics cards for laptops at this time frame. So it's kind of that double hit again, right? We saw this last year with 9th gen. We're seeing it again here with 10th gen. So kind of planets have aligned again, and giving that reason to buy that new machine. And what we've done in this family is, first off, we used to have with 9th gen just a 6-core 12-thread. We've introduced an 8-core 16-thread version as well. So now we have the same number of cores that we have on desktop. Guys, at the end of the day, for gaming, it's diminishing returns, right? Most games are 2-threaded, dual-threaded, maybe 4 threads, right? 8 is definitely an outside liar on how many games or even applications, for that matter, can take advantage of that number of cores, right? Some multimedia applications, assuming you're not using a feature like QuickSync, can use those, but not a whole bunch more. And we'll talk more about that. And also, so we have this new 8-core part in the Core i7. It turbos up to 5.1 gigahertz. So now you have a Core i7 mobile part that goes over 5 gigahertz, the Core i9 to 5.3 gigahertz. Guys, that's 600 megahertz faster than 9th gen. So big improvements in performance that you're seeing from this family. Again, we've integrated Wi-Fi 6, so it's for the modern home. Wi-Fi 6 is, again, if you get a core processor, it really should be paired with Wi-Fi 6 moving forward. Of course, and this is really, key in a gaming system, especially gaming systems that sell $1,000 or more, is to have that Intel H10 Optane memory with solid state drive in it. So as you remember, I showed you guys the demo. 2 applications running at the same time, or 2 instances kind of hitting that SSD, this thing really shines 2-3 times faster than just having a high performance SSD, say from Samsung, right, or Toshiba. So it smooths out those times when you're working on your PC and you're saying to yourself, what am I waiting for? Well, it's because the storage device, the SSD, is being hammered by more than one application at a time. So what do we get from, that higher performance at 600 megahertz? Well, we get about an extra 6% increase in frames per second. Now you might say, oh, 6%, that's not that much. No, for a gamer, that's huge. So big gains in gaming, we don't expect AMD to be anywhere near where we're going to be from a performance standpoint. I might even venture to say we're going to beat them on every game, but we'll see. AMD, I believe, just had an OEM introduce. I think ASUS just introduced a new product with their new H series, which is also 8 cores. We'll see, right? We're going to get that in lab, and we're going to get you guys some data to help fight against AMD. But I really don't think we're going to have a problem. All right, and this is the traditional slide. I'd recommend you keep this on you when you're talking to RSPs out there, right? The blue shirts, or you're doing trainings and such. It's a real handy thing to have, so you can see the transitions that are happening. And I put kind of the critical specifications on here. As an example here, let's look at the mobile, since we just talked about mobile. So here's the 9th gen Core i7. And then moving forward to 10th gen, you can see that we went from 4.5 gigahertz to 5 gigahertz, right? Same number of cores and threads. But then we introduced this new Core i7 with 8 cores that went all the way up to 5.1. So there's your 600 megahertz faster increase in performance, right? Even the Core i5 went up 400 gigahertz. And then you can see the Core i9s and such above that. I don't expect to see many Core i9s out there. They're still pretty darn expensive in the H series. So really the top that you're likely to see in retail is this Core i7 8-core product. On the right-hand side, all of the product specifications are here. So you have the full part numbers. We didn't have that last time, as well as the specifications and the frequencies. And you can see there's product that have gone up. 200 gigahertz is kind of the standard, though. Sorry, megahertz. And up to 300 megahertz on the Core i9 upgrade in performance. But really, the big change is the enabling of hyperthreading. So if we look, let's say the S series here, the Core i5 used to be 6 cores, 6 threads. Now it's 6 cores, 12 threads, right? And then likewise, it was 8 cores, 8 threads for the Core i7. Now it's 8 cores, 16 threads, right? So that's going to give us a big step up in performance. Just overall type of performance, you get an increase from that. Okay. Likewise, in the Celeron and Pentium space, a lot of changes are happening. Yeah, this is really hard to pull out of the information that's there. It's never, put on the fact tag or anything like that. But this is really for your information. If you do kind of hunt it out, you'll see new specifications, new part numbers for these various products. And I always encourage the retailers to go to the latest, greatest, because you do get a boost in performance. Even our Pentium Silver is going from 2.7 gigahertz up to 3.1. That's an extra 400 megahertz of performance there on that turbo speed. By the way, when you guys look at base frequency, that's really not telling of much of anything. The processor rarely spends time at that base frequency. That's kind of a worst case scenario, everything working against you type of thing, type of frequency. So really it's the turbo frequency or the higher frequency that makes a difference when you're comparing similar parts, right? Now, not to get confused, right? The silver parts, right? The ones that are in silver here are the small core, different architecture. So you're going to see higher frequencies there with more cores, but the performance is not as good as the gold series are the dark blue ones that you see here. Even though it's got fewer number of cores and a lower frequency, it's still better performance, right? Because it's a different architecture. Okay. All right, so what about U-series? U-series processors make up about 75% of all processors sold in the US. So it's a big market, right? And we just introduced back in holiday 10th gen. So 10th gen U series is out there. We made this. It was a critical decision to have two different versions, Comet Lake and Ice Lake. It caused a lot of confusion, right? Ice Lake was really the intended 10th gen part, where we boosted the AI performance, and we're going to talk a lot about AI.
So we more than doubled the capabilities, the performance on artificial intelligence workloads by adding new instructions to the processor, so new instruction set. And we also really increased the graphics performance. And really, we didn't necessarily do that for gaming, because these aren't gaming systems, and most mainstream users don't game. And besides that, most of the games that mainstream users would
play just fine on integrated graphics, whether it's World of Warcraft or League of Legends and those types of games. We're focusing a lot, and you're going to see this moving forward, using the graphics for AI workloads.
And we're doing some optimizations there, and I'll show you that on the next slide. Now, on Comet Lake U, that was kind of a filler, right? To make sure we have product, we added a couple extra cores just to kind of give it a, an extra kind of push over there. But at least we've integrated Wi-Fi 6 on both product lines, right? And Thunderbolt 3, while integrated into Ice Lake, is available for Comet Lake U. Okay, so these products are out, they're in the market. Why am I going over this again? We went over this last time. Well, AMD is introducing a new set of U-series parts. And you guys have to be really sharp on the differences in what they're going to be saying. I'm going to give you some insight to what they're going to be telling customers and how to combat that with facts. So we'll get you that in a second. All right, so let's talk a few minutes about advanced artificial intelligence capabilities. Now, you can run artificial intelligence workloads on anything, right? However, we're focusing on accelerating that. So 2 times faster, 4 times faster, 6 times faster, using new hardware and software capabilities for our processors over not having it. Our kind of first tool in the toolbox here, toolkit, let's say that, is something called Intel OpenVINO Toolkit. And what it is it's a software toolkit that we give to software developers that allows them to optimize their applications using this Intel goodness.
And even if you don't have the hardware components that I'm showing you on the right, it will still accelerate. And I've seen numbers as high as 2 times faster on AI workloads just from using our software development kit. So, and Adobe Sensei, a matter of fact, there's a little link there. If you have the
PowerPoint, you can click
on it. But I've put the link down here at the bottom. It's a real clever video that you can watch that shows kind of how Adobe is using the Sensei capability in their applications. And I'm going to show you some of that on the next slide. So if you are using the software, it'll work on all Intel CPUs, whether they're older or whether they're brand new, or whether they have the hardware capabilities. But if they do have special hardware capabilities, the toolkit will take advantage of that. So it'll automatically say, oh, this is an Ice Lake product. I'm going to use the new AI instructions that come with Ice Lake and make things even faster. Okay, so using the new instructions in Ice Lake. Also, there's links into the Iris Plus graphics. So we're using the graphics engine to accelerate, especially video type and content creation type workloads. And I'll show you some of those examples. So that's kind of the highest throughput engine, so to speak, for those types of workloads. And then finally, we've actually integrated a special piece called the Gaussian Neural Accelerator. And if you're telling customers and stores about a Gaussian Neural Accelerator, I think you're probably going too deep. But again, just so you know, we're integrating special goodness into the processor that can do AI workloads at very low power, like 10 times lower power than you can do it with the CPU alone, right? Now, they can't be super robust AI applications. They could be something like noise removal from a conference call. That's where that's going to be used. So a lot of focus from Intel. And guys, by the way, come our next product, you might have heard of it, it's called Tiger Lake, coming later this year. We're really doubling down on this, and you're going to see even more advances, big jumps in performance from an AI perspective. Okay, so it's good to start selling it now, so to speak. All right, so what can you do with AI? Well, these applications are shown here, very popular applications, right? Adobe's the #1 content creation application. Adobe Photoshop's #1. It's followed by Premiere. Lightroom's in there. Actually, Lightroom might be 2, and then Premiere might be 3. Regardless, very popular applications using these AI capabilities. And these applications I have shown here are using specific, unique Intel AI technologies. So whether it's the software or the hardware pieces I just talked about, those are in all of these applications. So it's already happening. Let me show you a couple examples of what I've done on this slide, and you're going to see 2 versions of this slide in your deck. This first one is I've linked each one of these examples to a video that's on my hard drive. Sorry, my SSD drive. So it's on my storage drive, so I can hit play and it plays very quickly. It automatically opens the video playback in full screen, and life is good. The next slide has just links to a Google site. So a Google Drive site, that Google Drive site is listed down here, but if you click on each one of these on the next slide, right, and on the upper right-hand corner, it'll say online content. Then these links change to the Google Drive, and they'll play from an online source. So if you do plan on showing these videos, no problem. You can show them all RSPs. They're all really public for the most part. I made most of them. I recommend you download them to your computer, change these links so that they match up to your videos, or you could just play the videos, show the slide, and then tab over to your folder and show the videos. Okay, with that said, let me show you a couple of examples. So I'm going to start with Photo Director. They have a capability called Photo Deblur, and it takes photos that are blurry, and using this AI algorithm, it says, okay, let me make this better. Different than what you've seen in the past, where they just kind of sharpen the edges. It actually intelligently goes through and says, this looks better, right? Based on all of the inputs that they have, right? The training that's happened with that application. So I'm going to show you an example here of how that works. So I've taken a photo. It was taken up at a zoo, actually, up in Oregon, and they kind of moved the camera, so it came out blurry. And if you go into this de-blur capability, it takes a couple seconds to run. It makes the picture much sharper, right? And I've kind of did a slider back and forth. You can see the strength of how much it changed the picture. But you can take pictures that are otherwise throwaway and save them. I actually have quite a few examples. Maybe I can make them available to you guys. It works pretty well as a slideshow, before, after type of thing. But it's one of those things that are easy to understand, right? Oh, you have some blurry photos? Well, hey, you know what? You might not have to throw that away, right? You might be able to save that. Here's a capability to do that. And this is Photoshop. Wait a minute. This is Cyberlink, right? Photo Deblur.
Now, by the way, guys,
so you know, it doesn't work on all blurry photos, right? If the picture was just flat out of focus when you took it, it's not going to help that much. I've tried. But if there's camera shake because it's, say, a low light application, or you just had the shutter speed was set too long, something like that, it does pretty darn good on those. Let me show you another example. This one is the Adobe Premiere auto reframe, and you can kind of tell what's going to happen by the picture here. I'm going to show you a video where someone is moving in the picture frame, and you want to take this video that was shot sideways, right, and make it for something you could, say, post on social media for for a different aspect ratio. And what this application will do, I'll start playing it. What this application will do is it will automatically find the subject, right, based on, you know, kind of what's predominant in the frame. And then what you can do is change the aspect ratio, and the application will automatically shift that window to stay focused on the subject. And it's super clever. I'm just showing an example here of just one person in the frame, but it'll automatically round so you don't have to do it. If the camera wasn't moving and the lady was skating from side to side, it would automatically track her in that video clip. Likewise, if you have two people in there and one becomes kind of predominant over the other, it'll pan over to the person that becomes more dominant and then pan back to the other person. It's pretty clever and saves a lot of time. Another example, all those old black and white photos. I'm going to show you a photo of my mother and her mother. So this is a photo that I grabbed from the big pile of old photos. And just for fun, it's like colorized photo. And again, this is happening probably 4 times faster than would happen on any other processor. This is being run on Ice Lake. And it does a really good job of you know, creating this photo. It even gives you some options on the right-hand side to choose different, you know, kind of variations of it. But it sees that they're people. It knows skin tones, right? If there was sky in the background, it automatically turns the sky blue. It turns grass green. And there's some other examples on that site here at the bottom of the page here. I've put in quite a few different examples. There's more than just these 7 videos. There's like 10 or more that have other examples. So you can play and find the one that you like, or you can make your own. The last one I'm going to show you is Photoshop, right? The most popular photo editing application or media creation application is Photoshop. And in this case, right, trying to isolate a person to say cut them out of a photo and put them in some other photo is very tedious. If you've ever used Photoshop, it can be a freaking nightmare trying to get a person's outline and you know, cut and paste it type of thing. So here's an example that's using these new AI capabilities, and it's using subject select, right? Which is the same as object select, but it just automatically, instead of putting a box around something, you can automatically just say, find the subject, it finds it, it outlines it, it knows it's a person. You can easily cut and paste it and do another photo, bingity boom, right? Very quick and easy. Where before you had to, you know, maybe use the magic wand tool or some other tool trying to get the outline of the person. And it works really well, much better than what you had before without the AI capabilities. Okay. So lots of examples here. They're all really good. There's the crisp one is also very good for noise removal. And when you're in a meeting, someone's making a lot of noise in the background, you can mute that out very simply. And that is actually using that neural accelerator, Gaussian neural accelerator chip in our Ice Lake product. Okay. So big push on AI from Intel. And again, we're doing this because we know this is where the market is going. A lot more of these applications are going to show up. So we're focusing a lot here. And again, you're going to see that in future products. Let's talk a little bit about our graphics strategy here. So again, a big reason why we're increasing the graphics performance is to utilize those for these AI application workloads. But of course, you know, you can play games on them, right? It's you know, better experience, higher frame rates for those mainstream users, and that's not a bad thing. Well, what I'm showing here is the capability of Ice Lake. So Ice Lake is the 10th Gen U series part. Sorry, and if you look at the far left, right? So here's our Core i7 Ice Lake part at 15 watts, and we're going to call that our baseline at 1.0, and this is using Firestrike as our graphics substore as our benchmark. Now, don't forget that Ice Lake, this part here, is twice the performance of 8th gen or even Comet Lake 10th gen, right? So we doubled the performance in Ice Lake over what we had before, actually what we still have with Comet Lake from a graphics perspective, right? And there are some systems out there that actually take that part, instead of running at 15 watts, run it at 28, and you get more performance still. Now, if we compare that to, say, the MX250, which is the kind of the choice today for mainstream laptops that want to put in a little bit better graphics performance, right? Well, it used to be twice the graphics performance, now not so much. If we compare it to that, so we look at the far left one, 15 watts. Now we take the MX250 running at 10 watts. Well, you still have to add in about 10 watts for the CPU. So therefore, you're at 20 watts now. So it's 5 watts higher and you get 20% better performance. Okay, right? Well, I could go from 20 watts to 28 watts and give you better performance still. And they'll say, well, okay, but we could go up to 35 watts and give you better performance still. Bottom line is, our integrated graphics with Ice Lake is about on par with the MX250. Okay, so you get roughly the same performance, but if you look on the right-hand side, you get it at a better efficiency.
Right? What does that mean?
Thinner platforms, cooler devices, that type of thing. So performance that's on par, I'll say, right? For the same wattage, it's pretty much right on top of it, but it's more efficient for using it. And what does that mean? Well, a lot of systems, or the systems that are out there, of the mainstream systems, it's like 5 to 10% of the systems out there have this MX250 or something like that, discrete graphics. If you go down this path with Iris Plus, right, you get very similar performance, longer battery life, right? Sleeker designs, you don't have that extra part generating heat that you have to cool, so it runs cooler, it's quieter, and oh, by the way, it's lower cost, right? Because even if you have an MX250, you still need the processor, right? You're just not using the integrated graphics for those workloads that need it. This theme will continue moving forward. So again, when we move to the Tiger Lake timeframe, huge improvements in performance and graphics. More than likely well above even the MX350 that's due to come out. I've seen rumors of it, though I haven't seen any. I've seen some leaked benchmarks. I haven't seen any that we've done on the MX350. Okay. All right. So what about AMD? Right? AMD has announced a whole bunch of new products. You're going to start seeing those. Like I said, the ASUS has a product. I think that just went on sale on Monday. So of course we're buying those, getting those in the lab, and start testing those, and we'll give you guys the results when those come in. But they also have a new U series part coming out that we need to talk about. All right, let me start with this. And this is important to understand and to communicate to customers, or even RSPs for that matter, right? Because they are going to be hearing two stories. They're going to be hearing the Intel story, and we're going to say, oh, our Core i7, mops the floor with their Ryzen 7, right? And AMD story, oh, our Ryzen 7 mops the floor with their Core i7. So it's going to come down to, who do you believe? And that's why I put together these, next couple slides, is to help you, first and foremost, believe this. And secondly, it's something you can use with the customers that you're talking to kind of help them understand what we're doing and what's real and what's not real, right? What's real and what's fake news. Anyway, so what this is a snapshot, and I've updated it. You guys have seen this before. I've updated it with 2020 data. So we refreshed this back in January to show what people are doing on their PCs, right? 50% of the time when a PC is on, right, it's looking at an internet browser. So internet browser performance is very important. And there's a lot of variation depending on which processor you have, right? 9% of the time, you're looking at some sort of Windows Store app, whether it's Netflix, Facebook, Messenger. By the way, the icons that you see here are the top applications for each one of these categories. 8% of the time, right? And that's kind of a misleading figure. I'll tell you that in a second. But 8% of the time, someone's playing a game. I can't even say that. 8% of the mainstream user time combined with the gamer time is World of Warcraft's number 1, League of Legends is number 2. God, I always forget the Blizzard game. Was number 3. Office applications, 7% of the time, Word's number 1, Excel, PowerPoint, communication apps, Outlook's number 1, Skype's number 2, right? Media consumption, iTunes, VLC player, game launcher, Steam, right? This is what people are doing on their PCs. And it's over almost 2 million systems that are running in the United States today, right? So very accurate, very large group. This isn't some survey over the phone. This is real data from applications, right? When you opt in to help Intel improve their product, right, which in this case 2 million or almost 2 million people have, that allows us to see how often they're using certain applications. All right, so now what does that kind of break down to? Well, really there's 2 different types of people, actually a lot more than 2, but really if you group them into 2, you're going to see a gamer persona and kind of a mainstream usage persona, which is, mainstream is everyone that uses a PC that really doesn't game. And that's by far the largest segment. And gamer usage is much different, right? Gamers aren't playing with PowerPoint, right? If they're using the internet browser, they're more likely watching a game, all right? That type of thing. And I have a breakdown on that. I'll show you guys that in a few slides. But if you look at that mainstream usage, that's what we're focusing on for products like the U series, right? And what we've used is Sysmark 2018. It is by far the best application. It hits all of the top applications that are being used by the mainstream user. It uses Google Chrome, it uses Outlook, it uses Word, Excel, PowerPoint, right? Acrobat, Photoshop, Lightroom, Cyberlink Power Director, WinZip, right? All the applications, and they're the real applications. They're not some synthetic made up bullshit type stuff, sorry, that others might use. And it's very linear. It's a time-based thing, right? It runs through scripts for all these applications and it times it. So it's just bona fide performance. And you can see all the lists, and I've gone through this before as far as, why use this benchmark, open consortium, that type of thing. Meanwhile, here's a quote from Lisa Su at CES, right? And they're showing a chart of combined performance of Cinebench plus 3D Mark 11. And they're saying, yeah, this is what, a typical processor, ultra thin 15-watt design, yeah, this is what they'd be doing, right? Which is baloney. Let me explain. So first off, Cinebench is a benchmark for an application called Cinema 4D, right? So I have this called out here, and these quotes I just took as of January 16th, right? So that it's all fresh data that's on the website today. So Cinebench is the benchmark for their own product, Maxim's product called Cinema 4D. And Cinema 4D is really used for 3D animation, right? This is used by studios to do animated movies, right? And for Maxim's client list includes, and I put this in quotes straight from their website, right? ABC, Blizzard Entertainment, BMW, CNN, right? Sony Pictures. Pixar also makes movies using Cinema 4D, Marvel Studios, ImageWorks, right? This is an application that doesn't run on a 15-watt laptop, and I have the data to prove that. It's an application that runs on racks of servers to generate a movie, right? Or worst case, big workstations. Okay, and again, we're able to see how many people have Cinema 4D on their systems and have run it at least once. And as of January 4th, right, only 2,800, right, 2,800 PCs out of the almost 2 million have that installed and run at least once. That's 0.15%. That is a horrible benchmark for the mainstream to characterize the mainstream user. Just a horrible benchmark. As for 3D Mark 11, okay, that's pretty good for gamers, right? Not for U-Series, because most U-Series systems, one, aren't at a gaming class, right? They're for mainstream type games. All right, so now if you believe that, right, then it comes down to, okay, so how do they line up using this, you know, as you say, best-in-class benchmark for the mainstream user? Well, their Ryzen 3 all the way up to Ryzen 7 products resides between Pentium Silver and Core i3. Now, this is the 3000 series parts, right? These have up to 4 cores. Now, AMD is introducing their 4000 series, and you're going to start seeing it in stores probably starting next month. And the sales pitch is going to go something like this, right? They're going to say, well, no, we now have 8 cores. Intel only has 4 cores, right? Our performance is twice that what Intel's is. Okay. Now they're going to be basing that. They're not going to be lying so much because there will be certain applications like Cinebench that can actually take advantage of all those cores very efficiently. And you know what? They will be able to show a better performance than our Core i7. That's why you have to bring them back in and say, no, wait a second, right? Very few applications can use that many cores. That's why we only have 4 cores in mobile today anyway, right? Desktop, yeah, we have more cores, there's more power, you know, who cares? No one uses them, right? I've got 16 cores on my system at home, and guess what, right? 14 of those hardly ever get used. So anyway, you guys are going to be up against kind of a very tough sell because they're going to be saying, oh, it has 8 cores and it's got twice the performance of Intel. And you need to reel them back in. Our projection for their 4000 series, their Ryzen 7 comes in between our Core i3 and our Core i5, right? So yeah, they're gonna move up. They're gonna leapfrog Core i3 with their Core i7 and Core i5. Their Ryzen 3 is going to be really close to our Core i3, right? But the 5 and the 7, we expect to come in right about here. Okay, so you have to be on your toes here, guys. They are also increasing their graphics performance, and they're going to say, oh yeah, we've got better graphics performance, which they will, at least for a short period, right? Come holiday, that is going to change. Regardless, again, the integrated graphics is not really used that much, right? These aren't gaming systems. For video editing and such, yeah, there might be some applications that use it, but guess what? You know, we've got quick sync video for transcoding video, and that's most of where those cores are used on media creation applications. Okay. Again, these parts, the 4000 series, are not available yet in the U series flavor. We're waiting to get those parts. When we do, we will give you this chart updated with the 4000 series, so you will know exactly where they come in. All right, so let's talk, just 2 more slides here. Let's talk a little bit about gaming. Again, looking at the same data, but now pulling out that gamer persona. And it's really easy to see that gamer when you have a big chart of how people are using their PCs. This gamer persona just pops out because 43% of the time they're playing a game, right? This represents 400,000 people here in the US. 43% of the time, they're looking at a game screen, right? So they're playing World of Warcraft, they're playing League of Legends, Overwatch, that's the game I forgot. Overwatch, or playing Overwatch, or they're playing Sims. Guys, those first applications that I just read off, the top 4, all of those play on integrated graphics with really no troubles, and you get a good experience, right? Is it competition level? No, right? But it's really, really good. So again, most of the mainstream games will play just fine on integrated graphics. Now, 43% of the time they're playing a game, guess what? 19% of the time they're downloading a game or waiting for a game to launch, right? So the game launcher, this also includes Discord, right, which is the voice chat that gamers use. So having that up. But again, unless the screen is active, it doesn't show up on this pie chart. So you have to have a game. The Steam application has to be that foreground application that's on your computer to count here. So Steam's number 1 from a game launcher perspective. And guess what? 26% of the time, guess what they're doing, right? They're watching games being played. My son fits this persona perfectly. And that's all they use it for, right? They're not they're not editing photos for their family, right? They're not doing PowerPoint or Excel. They're not on Outlook, right? Even the Windows Store apps are probably using that to messenger back and forth or post things to Facebook while they're waiting for the game to load. And I see that all the time with my son. These have to be benchmarked differently. That's kind of my whole point. We have the mainstream user. Sysmark is by far the best benchmark. And then you have your gamer usage, which is, you know what, you really have to do games. Yeah, you could do 3D Mark Firestrike or 3D Mark 11 and get kind of close as an average, but you really want to look at the top applications or top games that are being played and benchmark those. And while we don't have any data yet on their new 4000 series H series parts, right? Again, that ASUS is the first one out of the gate, and they were being touted at CES. We will have data for you soon. And again, I really don't expect them to beat us on really any game, but we'll see, right? We'll see how that turns out. But their specs right now are about 900 megahertz below ours from a frequency perspective. And I know not all cores are created equal, but we still think our cores are better than theirs. So we pull even further apart from those guys. So kind of stay tuned here. When we get more performance data, we will close back with you so you have that kind of real data to reference when you're talking to customers. Right? And with that said, guys, any questions that you might have or concerns, now would be a good time to bring them up.
Yeah, go ahead and unmute if you have any questions, guys and gals. Just don't forget that you're muted.
And you can't get.
Hey, I have a quick question. Can you hear me?
Sure, go ahead.
Hey, so this is Kelly. How you doing, Mike?
Oh, hey, Kelly.
Hey, about, I don't know when it was, maybe 6 or 8 months ago, we heard that they were going to change the badging and remove the generations from the badges on those systems. Is that going to happen so that we can't tell the difference between the the 10th gen versus 11th gen or 9th gen versus 10th gen?
Yeah, you might see that in the future, but all the new parts that are coming out this cycle will all have 10th gen on the badge.
Okay, perfect.
Mm-hmm.
Good.
Hey, Mike, with the new Comet Lake and S and H, are those still 14 nanometer or are they 10 nanometer?
They're still 14 nanometer. Right. We could still get higher frequencies for those systems that aren't necessarily power sensitive using the 14 nanometer. And again, that might change moving forward, but right now we could get the highest performance from 14 nanometer. And you see AMD struggling to hit our frequencies with their 7 nanometer TSMC stuff.
Cool. Guys and gals, any other questions? Or did Mike do an amazing job as usual? No question.
I was going to say, do you know what percentage Ice Lake is going to be out there?
Yeah, I don't. but you're going to see more and more Ice Lake as the year goes on, right? So the transition is happening. Comet Lake was kind of a filler. Ice Lake is really healthy. So you're going to see that switch over happen in the U series parts. One other thing worth mentioning on the U series parts is we also expect with AMD's new U series parts coming out, we still expect to have better battery life than them as well, which is a big selling point. We've seen that as kind of the number one regret after people buy a PC is it doesn't have enough battery life for them, or they wish they had more. We fully expect our 10th gen, whether it's Comet Lake or Ice Lake for that matter, to have better battery life than AMD's new parts.
Hey, Mike. Quick question.
Sure.
Hearing a lot in stores chatter about Intel potentially doing their own GPUs. Anything you can tell us about
that? Sure, and we've been public about it, so I can tell you at least, if nothing else, what we've said publicly. Yes, we are absolutely getting into the discrete graphics market. We will be competing head-to-head with AMD and NVIDIA, right? It's going to start light, right? You're going to see some product this holiday. At limited number of systems, toe in the water, right? Kind of that entry discrete graphics type of performance. But then the following year, you can expect the full stack, right? Desktop and mobile. So we're coming in, exciting times. We'll see how it turns out. But this year, just toe in the water, right? And it's hardly even worth mentioning, in my opinion. But next year, it's going to be big.
Hey, Mike, you mentioned on the new 10th gen desktops with the Turbo Boost going to 2 cores. Do we know what AMD's Turbo Boost capability is on cores?
We know what their frequencies are. We do not think that they're boosting to that top frequency with more than 1 core. We really doubt it because they're struggling just to hit the frequencies that they're hitting now. But we'll see. Until we get the parts, we don't know. In general, by the way, even when you see 2 different turbo frequencies, you know, say AMD versus Intel or whatnot, how long they're able to stay at that turbo frequency is also a big factor. And AMD had, especially in the desktop space, man, they were really struggling. They would hit their boost frequency for like less than a second, and it would come down right away. So even when you just look at those frequencies, you might think, oh, it will run up this fast. Yeah, guess what? You know, depending on the processor, it could run there for 30 seconds, right? It could run there for less than 1 second. And it's a big change in performance. And that's why, again, you can't just go by specs. You have to go by performance and look how it does during, you know, typical workloads.
Will there be a SE version?
I'm sorry, could you repeat that?
Will there be, like on the i9, Intel just came out with a special edition where it does hit the clock on all the cores? Will we be coming out with something like that?
Oh, yeah. You know what? I've heard rumor that maybe we might. At the time, I thought it was kind of a bad idea. But as it turned out, you know, we got pretty good feedback from doing that. And if we do it, it's going to be pretty killer from what I understand, but nothing definitive yet.
Cool. Thanks, Brian. Thanks, James, Jason, for questions. Anybody, and Kelly, of course. Any other questions from anyone else? Awesome. Looks like we kept it to just right at an hour, Mike.
All right. Great. All right, guys. Sorry we couldn't meet face to face. You know, it would have been great to see all of you again. But you know, get used to it, right? This is going to be the future. Next time I'll show my video too, or my face, so you can at least see me.
Awesome. Well, thanks everybody for being on today. Everyone should have received the deck. We'll make sure you have access to the videos, as Mike indicated, and we want to make sure that this is taught down to our assisted sales group as we go through our virtual training plan. Mike, right now the team is not working in stores, as you know, so we're working on a virtual training plan for them to do in the meantime. So they'll be sharpened tools, as Jeff would say, once we're ready to get back into the stores. So
Okay.
we'll be excited. Thanks, everybody. Appreciate you being on, and have a great afternoon.